Okay, for this question, it is mainly on the application of differentiation. So the application includes stationary point, it includes equation of normal, and the last part is more of like explanation. Okay, so first of all, the question shows a curve, and they give us a restriction on the range. So whenever there are some range given, so do take note of it. Okay, so the first part would like you to explain why dy dx has no stationary point. You do need to recall the definition of a stationary point. So for stationary point to happen, you need to be able to do a dy dx equal to 0 in order for stationary point to happen. So since the definition of stationary point involves dy dx, so the first thing you should do is execute your dy dx. So in this case, I got to be doing my dy dx using a quotient rule. So I'm not going to explain the quotient rule part. So you should execute your quotient rule to get your dy dx. So where you get your dy dx, you are supposed to explain. The critical explanation is the denominator. The denominator is a squared function. So it is a must that you must explain that it is a positive function. The numerator is confirmed positive. Okay, you do not need to explain that the numerator is positive because the numerator is only a number. So we can see that the number is positive. However, the bottom function, the denominator function, is not a number. You need to explain that it is a positive function. So if the numerator is a positive number, the denominator is a positive function, that will make the whole fraction positive. So that will make the whole fraction positive, and then the dy dx will always be positive. So from here, there's actually two ways of explaining. So since dy dx is always positive, then it cannot be equal to 0. So because it's always positive, then it will never be equal to 0. And that's why there are no stationary points. Alternatively, we use the idea that dy dx is always positive. It's actually an indication that it's an increasing function. So increasing function is that if it will just keep on going, it will be increasing. So because of this, right, it will never come down. So it will not have a turning point. So for this question, right, they can actually rephrase it to ask you to explain that it is an increasing function, because it will serve the same working as well. Okay, so use the dy dx to explain that it has no stationary point, or you can be asked to explain increasing function. Okay, so this is the critical explanation. You must explain this part. You must say this part, or else you will have marks deducted off. And the second part talks about there is a point on the curve. So there's a point P on the curve, and the gradient is half. And then there is a normal. So actually you got to go back. So from here, I know that the gradient, the tangent is half. And then this is a normal. So there will be a perpendicular relationship. And then the question says that the normal intersect the x-axis at A and the y-axis at B. So I will need to find the area of this triangle here. So in order to find the area of this triangle, you just need to be getting the coordinate of A and B. So to get the coordinate of A and B, you need the equation of normal. Okay, so you need the equation of normal. However, at this point, you don't even have the coordinate of P. So it's critical that you have the coordinate of P first. So you are going to execute this fact that the gradient of tangent is half. So gradient of tangent means dy dx So you should be able to execute your dy dx equal to half so that you can find the x coordinate. So essentially you will get two coordinate if you set dy dx equal to half. So you take the one that is positive. So I'm taking the one that is positive and put it back into the curve equation. So don't put it back into dy dx. So this is the curve equation. You will get the coordinate of P. Because if you don't have the coordinate of P, it's not possible to find the equation of normal. So since I have the gradient is half, gradient of normal will be the reciprocal. So I'll be making use of this to find the gradient of normal. And with the gradient of normal, I will make use of the coordinate of P to find the equation. So this is the equation of normal. So with the equation of normal, execute the x-intercept and y-intercept to find A and B. And you will just be doing a half-term base part. Okay, so I don't think this part is very difficult if you already know the steps to equation of normal very well. Okay, part C can be a bit difficult, but you follow what they are telling you. Okay, so you follow what they are telling you. So they are telling you that there is a horizontal line. So this horizontal line will not intersect the graph if, let's say, they are saying that it will not intersect the graph if C is greater or equal to 4. That means if the horizontal line is y equal to 4, if the horizontal line is y equal to 5, if the horizontal line is y equal to 6, it will not intersect the graph. But they will like you to express in that format first. So this one appear a few times over the past O-level question. So to do this, it is a long division. So it is a long division because it's an improper fraction. The numerator is degree 1, the denominator is also degree 1. Okay, so you just do a long division. After you do the long division, so this will be the quotient, this will be the fraction. So this one will be the proper fraction already. So I am supposed to use this to explain why a horizontal line higher than 4 cannot intersect. So I'm going to use this. So this is my graph. So this is my curve. So my curve is this. So I change the format of my curve so that I can find the lowest or the highest value. Okay, so don't forget, when we start the question, right, we got a restricting x value. So we are given that x is greater than -1. So if x is greater than -1, if you do a +1 on both sides, you will achieve the denominator here to be positive. So the denominator will become positive. The numerator is already positive. That's why the whole fraction is positive. Okay, so there is a negative that I got to account for. So I'm going to multiply -1 on both sides. Multiply a -1 will reverse the sign. Then after that, I'm going to do a +4 on both sides. So I'm going to manipulate from the x greater than -1. I manipulate from there until I get my graph, and I'm able to deduce that my graph is always below y equal to 4. My graph is always below y equal to 4. That's why horizontal line that is 4 or more will not be able to cut the graph. Okay, so that is the interpretation. So they are asking you to explain why horizontal line above 4 cannot cut the graph. So I get the range of the graph. the graph ends up always lower than 4. So you can visualize like this. So I just randomly draw. So there's a line y equal to 4. Okay, I just anyhow draw the graph. So the graph always ends up below 4. So any line that is 4 and above technically can't cut it. So you follow what they are telling you. They are guiding you. So do exactly what they are saying. So don't just leave it blank and say, I don't know how to do. So exactly what they say, express this in terms of this. So you go and do the long division. So after this, you explore what can you do with the expression. But of course, you need to take note that you are actually given x greater than -1 to start with. Or else, I think this question, most people might end up just getting 1 mark if you can do your long division correctly.